Here's the law of sines, example 5 from your book, where we're going to have two triangles that are going to exist with a side-side angle triangle. So we want to solve this triangle, finding the missing two angles in one side. So if you remember from the previous video where we have to find the height, so I'm going to be looking at this purple writing here where we want to find this height right here. So to find that height, we multiply side B times the sine of A. So side B is 62, angle A is 40. Substitute into that equation, 62 sine of 40 degrees. Now I'm going to grab my graphing calculator here. Hopefully this will show up. Make sure your mode of your calculator is in degrees. So I'm going to change it to degrees. And then quit. All right, there. All right, so now we're going to type that in. So 62 sine of 40, enter. And we're going to get 39.85. So if we look back on that previous slide, the rule when you have two triangles existing right here is when your A value is greater than your height, and then your A value is also less than B. Okay, so that's what we're looking at here. So our A value, which is 54, is greater than your height. Also, your A value is less than your B. So we're going to have two triangles existing. So go ahead to the next slide. When we have two triangles existing, we have to find that missing angle B first. Okay, so we're going to be labeling these angles as B1 and B2. Or B sub 1 and B sub 2. So I just took from your textbook so you can see the visualization of the two types of triangles. So this will be our first triangle that we're going to find. So here it is over here in the blue. Okay, so we have our given angle 40 degrees, our side A of 54, our side B of 62. How we find that missing angle B1. So step 1, find the first triangle's angle B1 using the law of sines. So we say the sine of B over little b equals the sine of A over little a. Just like we've been doing before. So we substitute in angle B, which is going to be unknown. Little b is given to us as 62. Big A was given to us as 40 degrees. And then little a is 54. So we're ready to cross multiply. So 54 times the sine of B equals 62 times the 40 degrees. Now we're ready to undo. We want to isolate that sine of B. So we undo by dividing by 54, so 62, sine of 40 degrees over 54. And then we would type this into our calculator. So I'm going to move this off to the side a little bit and bring up that calculator. So 62 sine of 40 degrees, enter, and then divided by 54, enter. here's what you're going to get. You're going to get a decimal value. We worked on in Unit 4 and in Unit 5 called inverse triangles. We have to find out what is the measure of that angle. So we go to second sine and then type in that decimal value or call it up, second answer. Enter. And there is our first angle, 47.56 degrees. I'll move that off to the side. So our first angle, once we did that decimal value about 0.7, angle B is the sine inverse of 0.7, and I rounded that a lot. But we're going to get an angle of about 48 degrees. All right, so there's our first triangle's angle, and I'm going to go ahead and label that B1. So if we look back up at our picture, this is our B1 that we just found. To find B2, you're going to use the Triangle Sum Theorem. These two angles, B1 and B2, are going to add always to 180 degrees. Always, always, always. So I'm just going to go ahead and add a page here. So to find angle B2, the second triangle's angle B, is you take 180 degrees and subtract it from angle B1. So 180 degrees minus angle B1, which we found to be 48 degrees using the law of sines. So angle B2 is 132 degrees. All right, so let's just go back to that picture. So here's what we just found. We found this angle right here to be 132 degrees. It's an obtuse angle, where angle B1 is an acute angle. Now we have two more pieces left to find. We have to find the measures of angle C's and the sides of C's. All right, so here we go. And change colors again. So to find the measures of those angles C1 and C2, we're just using the Triangle Sum Theorem. Use the Triangle Sum Theorem to find those last angles. To find C1 and C2, the two triangles. So C1 is 180 degrees minus angle A minus angle B1. Sub it in. 180 degrees minus 40 degrees minus 48 degrees. Remember that 48 degrees was a rounded answer, so we're at 92 degrees. All right, one more of these. Angle C2, same process. 180 degrees, subtract out angle A, and now subtract out angle B2. 180 minus 40 minus 132 degrees. And we'll get 8 degrees. All right. So what we just found are the angle C's in both of those triangles. So here's our angle C1, here's our angle C2. We have one thing left. We need to find these side lengths, C1 and C2. We just use the law of sines like we've already been doing in the last videos. All right, so here we go. Use law of sines to find side C1 and C2. So here we go. Sine of C1 divided by C1 equals sine of A over A. So sine of C1 is 92 degrees over C, which is unknown, sine of A of 40 degrees over little a of 54. So we've been doing this a while, so we'll shorten up this cross multiplication. So when we're done, we get C sub 1 is 54 times the sine of 92 degrees over the sine of 40 degrees. We would type this into our calculator and simplify it, and C sub 1 is about 84 units. All right, one more left. We're almost there. Here we go. We're finding side C2. So the sine of C2 over side C2, the sine of A over little a. Here we go. Sine of 8 degrees over C sub 2, sine of 40 degrees over 54. Cross multiply and undo. C sub 2 equals 54 times the sine of 8 degrees over the sine of 40 degrees. Type it into your calculator. C sub 2 is about 11.7 units. So now if we go back to here, we just found those last two sides here in the purple.